Working with OSPF is a lot of fun. In the previous video, we took a look at some of the syntax to get OSPF up and running on the router, including the command router space OSPF space a process ID followed by one or more network statements. In this video and lab, I'd like to give you some hands-on practice in working with those network statements to get a better understanding of how they work, including how that wildcard mask operates. So let's do this together. Let's go ahead and imagine we have a router. We'll call him router 1. And router 1 has 3 networks attached. Let's imagine those 3 networks. We'll put them over here. Let's imagine that he's got the 10.0.0.0 network with an 8-bit mask. So that means that on one of these interfaces, we've configured IP address 10.0.0. something so that all of his host bits are not 0, and then a mask of 255.0.0.0. Pressed enter, did a no shut, and poof, that router is now directly connected to that 10 network. Let's also further imagine that he's got the 172.16.0.0 with a 16-bit mask, and also 192.168.1.0 with a 24-bit mask. So great, we have 3 interfaces, they're all up, 3 IP addresses on those respective interfaces, so the router believes it's directly connected to these 3 networks that are listed right here. So what would the mask be? As we warm up to this idea of wildcard masks, what would the normal mask be for this network right here? Now, if we're looking at this and saying, Keith, it's an 8-bit mask, that means we have the mask is in dotted decimal 255, and then the rest is 0, based on our knowledge and information we have about masks and how they work. Fantastic. And let's do the same thing for 172.16.0.0/16. What's its mask in dotted decimal? And that would be 16 bits, so there's 8 bits there, and 8 bits there, and then 00. So that represents a 16-bit mask. And for a 24-bit mask, it would be 255, 255, 255, and 0, just like that. So if we were going to include these 3 networks on R1 into its OSPF process, we'd go into configuration mode, we'd type in router, space, OSPF, space, a process ID. You pick your favorite process ID number, we press enter, and then we would start doing network statements. So our first network statement could be something like network, and then we'd list them. So network 10.0.0.0, 10.0.0.0. Now, a couple things about network 10.0.0 that we probably are both on the same sheet of music about. If it's an 8-bit mask, that means that this portion right here, the first octet, is the network, and the rest of it is available for host addressing. So if we're doing a network statement, and we're telling the router to include any interfaces that begin with 10, what we'd want to do is we'd say we care about matching on this first octet of 10, but we don't care about matching on the last 3 octets. And that's where the wildcard mask comes into play. Now, one way of thinking about a wildcard mask is thinking of it as an inverted mask. And I'd like to point out right here this word mask. See how mask is right there? And then right below it we have wildcard mask, and it looks like it's inverted or upside down. That is a great way to remember their relationship. They're basically inverted. What does that mean, Keith? Well, that means if there's a 255 in the mask, the wildcard mask is going to be the exact opposite of it. So the wildcard mask could be a 0. And if the mask is a 0, the actual opposite of that would be 255. The 0 representing all zeros, and the 255 representing all ones. And that would continue here as well. And if a light bulb goes off, that's awesome, because that's a great way as a starting point to remember how wildcard masks work. They're just an inverted mask. So for the rest of this network statement, we'd put a space here, and we'd put in the wildcard mask of 0.255.255.255, followed by the keyword area, and then the area that we want that network to be in. In our topology, we're using area 0 for everything. Okay, so now it's your turn. If we have this network, 172.16.0.0, and it's got a 16-bit mask that looks like this, my question for you would be, what would the wildcard mask? Again, think of inverting it. So if we pause for a moment and say, okay, I think I got this. If it's a 255, I make it a 0. If it's a 255, I make it a 0. If it's a 0, I make it a 255. And if it's 0, make it a 255. Now, what we're doing in this video is we're focusing on networks that have nice, clean boundaries, where the separation between network on the left and host on the right is right between 2 of the octets. In the next video, we'll deal with how we handle subnets. And so if we were going to add this network as a network statement, we would say network, and then put in the network 172.16.0.0 space, and then the wildcard mask, which means we only care about matching on the first 2 octets. And that'd be 0.0.255.255, and then we'd follow it up with an area, space, and the area we want that network to go into. In this case, area 0 again. And then for the last one, we'd put in the network statement, we'd specify the network itself, and then we would specify the wildcard mask of 0, 0, 0, 255. And now that we've taken a look at this conceptually, here's what I'd love you to do. In the hands-on lab, I would like you to go to router 1, and I have conveniently included these loopbacks for us so that we can actually practice this. I'd like us to go and create router OSPF 1, that process, and then add the network statements for all 3 of these networks. And if you're the kind of person who likes a little extra challenge, if you want to pause me right here, please feel free to do it. Pause me, do the lab, walk through it, do the show commands, verify, and then hit play. And then we can confirm that you got the same results based on your network statements. So, did you pause me? All right, we're going to go through the walkthrough right now in the virtual lab. All right, so here on R1, a good starting point would be see if we have the routes local on this router to begin with before we try to add them into OSPF with network statements. Great way to do that is show IP route and press enter. If you have lots of different routing protocols, you could thin it out by saying connected, and we'll hit space to continue. And let's look for the 3 networks that we're focused on. We have the 10 network, great, 1 out of 3. We're looking for the 172.16 network with the 16-bit mask, great, that's 2 out of 3. And then we have the 192.168.1.0 network with the 24-bit mask, fantastic. It's time to go into OSPF. So we'll go into configuration mode, router, OSPF. We'll select a process ID of 1, press enter, and then we'll add our network statement. Let's add the network statement to include this guy first, the 10 network. To do that, we'll type in network, space, and then we'll put in the network itself, 10.0.0.0, space, and then we'll put in the wildcard mask that says we only care about matching on that first octet, and that's enough. The last 3 we don't care about. So the wildcard mask, based on our plan, let's take a look at our plan. Our wildcard mask is going to be 0, 255, 255, 255. So let's put it in. So back at the CLI, we'll do 0.255.255.255 space, area, space, and we'll add that to area 0, press enter. And now is the moment where we can test and verify based on what we just put in, whether or not that network and that interface with that network just got put into OSPF. And here's how. We'll do a show, and because I'm in configuration mode, we'll add a do show IP OSPF interface brief, just like that. And the crowd goes mild. So loopback 10, the interface that is directly connected to that 10 network, that is in OSPF. That means our network statement succeeded. So we have 2 more networks to add. We have the 172.16 with a 16-bit mask and the 192.168.1 network with a 24-bit mask. Let's do it. So we'll type in, still in router configuration mode, we'll type in network, space, and we'll go for the 172.16.0.0. The wildcard mask says we care about matching on the first 2 octets, and we don't care about matching on the last 2. And then we'll add a space, area, space, and plunk that network into area 0. And then we'll hit the up arrow key a couple times with a do show IP OSPF interface brief. And so the purpose of this lab is to give you that hands-on practice so you can do a command, then you can see the results. And if it doesn't match what's happening here or what you expect to happen, that's an opportunity to go back in and say, oh, that was the difference, or this is why it happened. So take advantage of the hands-on lab to get that practice with wildcard masks and network statements. So we have 1 more network to go, and that's 192.168.1. Let's do it now. So we'll do a network statement for 192.168.1.0, and we'll give it a 0.0.0.255 wildcard mask, meaning we care about the first 3 octets matching, but not the last. And then we'll specify area, space, 0. And we'll press enter. And then we'll do the up arrow a couple times and do a do show IP OSPF interface brief. And we got it as well. Now, another way we could have done that last network statement, or any of these for that matter, is we could have put the exact IP address of the interface that's connected to that network. In this case, .1, that's the IP address of R1 on that network. And then we could have said all zeros here. And what that means is, hey, these 32 bits have to match. And if it does, the router says, okay, great. This matches this interface. This interface is connected to that network. I'll add that network in. So this would have effectively the same result as the one we just did. I'm going to do a Control-C. I'm not going to issue that command because we already have the network statement and we already have our 3 networks inside of OSPF. So in this video in lab, we identified that a wildcard mask is sort of like a mask that's been inverted. And if we think of an M for mask and W for wild and how it's flipped, that's a great way to remember that. And what we did here was on clean boundaries between two octets. In the next video, I'll walk you through a pretty straightforward way of setting up a correct wildcard mask if you're dealing with subnets. So I'll see you in that video in just a few minutes. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.